Cutting and pasting lizards with CRISPR-Cas9. They are about a finger in length and come in shades of gray, brown, and green. It was considered ideal for genome editing due to its small size, ease of husbandry, long breeding season, and its short generation time. One of the biggest challenges with reptiles is when injecting CRISPR-Cas9, it is unknown when fertilization occurs because sperm is stored for extended periods of time. As a result, scientists injected CRISPR-Cas9 into the unfertilized eggs and the breakthrough happens. CRISPR-Cas9 made DNA.
Scientists began searching for ways to alter genomes in the 1960s. Working in test tubes, researchers at different universities bombarded DNA with various combinations of molecular information all derived from bacteria. The researchers eventually landed on a recipe for cutting and pasting DNA. For the first time, it was possible to mix genes to create hybrid sequences. For nearly 10 years, researchers struggled to find a better way. Until 2012, CRISPR came along. CRISPR is short for cluster of regularly interspaced short palindromic repeats. CRISPR consists of two components: the Cas9 protein that can cut DNA and the guide RNA that can recognize the sequence of the DNA to be altered. To use CRISPR-Cas9, scientists first identify the sequence of the genome they want to modify. Then they create a specific guide RNA to recognize the particular strand of DNA they want to change. At that point, scientists can then edit the existing genome by either modifying, deleting, or inserting new sequences.
For the procedure, a female lizard is first placed under anesthesia. They are then placed under a dissecting scope. The lizard is cut vertically on the left or right side to gain access to an ovary. Oocytes that are within 0.75 and 5 millimeter diameter are microinjected. Once the oocytes are microinjected in one ovary, the incision is then sealed with veterinary glue. The procedure is then repeated on the opposite side. A total of 10 oocytes will be microinjected within one lizard.
This experiment was confirmed when scientists edited a gene for an enzyme that helped produce skin, eye, and hair pigment. After they discovered that when the gene was inactive, the pigment of color was absent, they decided to observe the outcome. The result from this experiment was an albino lizard. They lack of dark pigment in the hair, skin, and eyes. As a future application, this experiment can be applied in other species to study gene functions and uncover the genetic roots of other genetic disorders.